Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, let's take a look at our homework for lesson 4.1.7. All right, so the M&Ms for this is getting into your journal officially, the representations of patterns web, which basically just says you can represent a situation in a number of different ways, different representations. We started off with patterns, like this tile pattern here, but eventually that becomes word problems. And then you can put information into a table from that pattern, or you can create a rule from the pattern, or you can create a graph, and you can go back and forth between these to help you better understand the situation, and then use all of this information to help you solve a problem. So if we look at this, here's the tile pattern where you start off with figure 0 has 3 figures, 3 tiles. So that corresponds to the starting amount in your rule, or when x is equal to 0, y is equal to 3, which is your y-intercept in your graph. And then we're looking to see, all right, so how does this pattern grow? It goes from 3 to 5 to 7, and every single time you get that growth happening where it increases by 2 every single time the figure number increases by 1. So that's the growth factor that you see here, which is the slope of the line. When you see it, let's go ahead and do it this way. When we do our growth triangles, it always goes up 2 for every one that it goes to the right. So that means that the slope ratio is equal to 2, or 2 over 1. And then you can see that happening here as well, where every time x increases by 1, y increases by 2. So you see the starting amount in every representation, and you see the growth factor in every representation. All right, so let's take a look at this. What are we doing here? We are taking our generic formula for y equals mx plus b, which is the form for a linear equation where m is the growth rate and b is the y-intercept, or the starting amount. So it might be good for you to identify each of those within the rule, and notice how I turn this around because it's backwards. I always like to have the x term listed before the constant term, so it's obvious what your growth rate is in each one of these situations. And here, because it's y equals 3, that meant that the growth rate, whatever you multiply times x, was equal to 0, because it always zeroes out and y is always equal to 3 no matter what. Okay, so what do I notice about the first equation? It starts at 3, where y is equal to 3, and it goes down 2 for every time x increases by 1. So we can get 3 points on there. We could label them, but I didn't label them because I wanted to show the growth triangles in there. But this point right there would be 3. No, that's not 3. What is that? That's 2, right? So this is where x is equal to 2 and y is equal to 1. So let's plug that in. When x is equal to 2, no, that's not 1. That should be -1, shouldn't it? Let me write that a little bit more clearly, because that is below the origin, so that's a -1. Okay, so 2 times 2 is 4. 3 minus 4 is -1. All right, that works. Let's try B. In this case, there is no y-intercept, which means it must have been 0, right? Y equals 2x plus 0, which means our y-intercept is going to be here. And this is a proportional relationship because 0, 0 is one of the points on the graph, and the growth rate is 2. So it goes up 2, 1 to the right, up 2, 1 to the right, and so on and so forth. So this point right here would be 2, 4, which if you put 2 in for x, you get y would be equal to 2 times 2, which is 4. For C, the growth rate was 0, so that means it's going to be a horizontal line. It's never going to go up. It'll go to the right or to the left, but it won't go up or down. So that with a slope of 0, y is always equal to 3 for every one of these points. So the y-intercept is at 0, 3. This point is 1, 3. This point there is 2, 3. Every single point on that line has something in common. They all have y being equal to 3. And then this last one has a y-intercept at 3, And then the growth rate is actually just like with A, it's going to go down instead of up. It's going to go down 1 unit for every 2 that it goes to the right. So this point right here would be 2, 2. This point right there would be 0, 3. So let's check. What is half of 2? It would be 1, but that would be -1 because it's a -1/2 times 2. So -1 plus 3 is 2. Yes, it is. That proves we've got that correct. All right, now let's look at some tables and see if we can figure out patterns of growth. It looks like this guy is increasing by 2 every single time, and the y-intercept happens to be 5, so y equals 2x plus 5 finds this table. And now when you know what x is, you can figure out what y is, and if you know what y is, you can figure out what x is by doing simple algebra. Here our y-intercept is at 4, and it looks like it's going down by 2 every single time. So our growth rate is -2 and our y-intercept is 4. So this rule is y equals -2x plus 4. So once again, if you know what x is, you plug it in here and you solve for y. And when you know what y is, did we have to do that? We didn't. Okay, good. And this one, there's the y-intercept. And what is the growth rate? It looks like it's going down 3 every single time. So y equals -3x plus 1. Once again, if you know what x is, you plug it in here and you solve for y. And if you know what y is, you plug it into the y and then you solve for x. All right, so for a tile pattern with the rule y equals 6x plus 4, where x represents the figure number and y is the number of tiles, which figure number has 40 tiles in it? All right, so y represents the number of tiles. We would want to put that in place of the y in our rule. So now we're going to subtract 4 from each side. Then we get 6 x's because they zero out. 6 x's equals 36. Then we divide this by 6 and we get x is equal to 6. So figure 6 would be the figure that has 40 tiles. Now, if you want to prove it, you absolutely can prove it. We know the growth rate is 6. And we know the y-intercept, when x is equal to 0, y is equal to 4. So if it increases by 6 every single time, this would be 1 is 10, 2 is 16, 3 is 22, 4 is 28, 5 would be 34, and 6 would be 40. Boom, right there you go. There's the proof that figure 6 is going to have 40 tiles. We proved it 2 different ways. Josie and Jules are building a model car. They find that the real car is 54 inches tall. No, what? Oh, 54 inches tall and 180 inches long. They decide to make their model 3 inches tall, but now they're having a disagreement. Josie thinks their model should be 10 inches long, and Jules thinks it should be 129 inches long. I don't think that's right. Help them settle their argument. All right, so when we're talking about scale models, you're talking about proportional reasoning. So we are going to set up a ratio here where you've got the height of the car in real life over the length of the car in real life. And we're going to have that correspond to the height of the car in the model with the length of the car in the model. So this would be proportional reasoning according to a scale factor. And what is that scale factor? It looks like from going from the model to the real, what is 54 divided by 3? 54 divided by 3. All right, so you're multiplying every inch. For every 1 inch on the model, that's 18 inches in real life. So essentially what we do here is we're going to divide this by 18, and then you'll divide this by 18 to get x equals 10. So that means that Josie was correct. Now, that's not the only way you could have solved it. You could have also cross-multiplied and said 54x is now equal to whatever 3 times 180 is, and I believe that is 540, right? Because 30 plus 24 is 54, yes, and so we'll add the 0. So now when you divide this by 54, you also get 10. Now, a third way that I did it was I chose to simplify this fraction. And I simplified it down to a nice and easy number. In fact, it seems like I could have divided both of them. What could I have divided both of those by? I could have divided the top and the bottom by 18, and it would have just become 3 over 10. So why not just do that? I don't know. At any rate, a few different ways to get to our answer, and definitely Josie is right with 10 inches for the length of their model car. And that's it for today. All right, so that ends our 4.1.7 homework. Now we're going to get into preparation, I'm sure, for our Chapter 4 test. So let's move on to the next activity. Take care. Bye.
Hey, feeling good, like I should. When in dark, walk